Go Language Programming, Chapter 3, Unit 7. In this unit, we will go over maps in Go language, adding items to a map, retrieving map items, check for map key, iterate map elements, deleting map items, and maps are similar to slice. We will see how the similarities are there in both of them. So let's start with maps in Go language. So programming languages have the concept of dictionary or hash type. So these types are commonly used to store data in pairs with a key that maps to a value. So in Go language, the map data type is what most programmers would think of as the dictionary type. Okay, so it maps keys to values, making key value pairs, and provide a way to store data without relying on indexing. So like if you would have arrays or even slices, you have to rely on the indexing. This allows us to retrieve values based on their meaning and relation to other data types. So it makes things much more easier, simpler. Basically, a map is constructed by using the keyword map followed by the key data type in square brackets. Okay, and we will actually see it pretty soon. Followed by the value data type. The key value pairs are then placed inside the curly braces on either side. Okay. So basically, map is a keyword that you can use, and let's see how it is done here. So Go provides a built-in map type. Okay, so you don't really have to write a code for it, like you may end up writing a code in C language or in some other languages that implements the hash table. Okay, so in earlier days of the programming, people had to write a code like in C language for the hash table, and that involves quite a few things. But here, this Go language provides the map, which is essentially like a hash table. So maps in Go associate a value to a key pair, key type. Okay. So the value can be retrieved using a corresponding key type. Okay. So you can, if you know the key type, then you can retrieve its value from the map. Map can be created using composite literal, just like the way that we created the slices, or using the make function. Okay, so there are two ways to create the map. So if you use the composite literal, then this is the syntax. You have a map, and within the square bracket you give a type, and then you have another type for the value, and then within the composite literal, you give all the key value pair, okay, and then you assign it all to the some variable name. In this case, it is taking the short uh, um, uh, assignments to assign it to this variable called keys. So a map can be created by passing the type of key and value to the make function. Okay, so that's how you can create the map. So basically, uh, one way was that we just discussed by using the composite literal, and the other way is to use a make function. So make function takes a parameter of type make, okay, uh, and or the parameter of type map with a type of key in there and type of value. So you tell what type of a key is going to be, and you tell the type of value. Okay, that's the syntax to create the map. So here we are using a map to create this person's salary. So in this case, we have a map with this key type, which is a string, okay, which will hold the names of the person, and then value will be the salary, which will be the integer type. Okay. So the above line of code creates a map named person, which has string keys and int values. Okay. So it's not necessary that only string types should be keys. So basically, right here that we discussed just now, that this is string. It doesn't have to be a string, it could be any other data type. Okay. All comparable types such as Boolean, integer, float, complex, strings can also be keys. So it could be any of these types that you could make a key. You have a zero value of a map, which is basically a nil. So if you just declare a map like this, okay, that means the it is nil. So items cannot be added to nil map. It will create runtime. Okay, you cannot add any items to it. So you have to use a make function to initialize the zero value map, or use a composite literal. Okay, so either you use a composite literal or use a make function. So if you are using a make function, you can have the this make right there, and then tell that okay, you want to create the map. Okay, in this case the keys and the values, they both are going to be the string type. Or you can use a composite literal. Okay, in this case, the way that this is declared, and also this one, they both will be empty maps. Okay, so basically this is considered a nil map. These both are considered as an empty map. So two maps cannot be compared. You cannot compare two maps with the um, equality operator. Okay, so the equality operator can only be used to check if map is nil. So you can use this equality operator that if the map is nil or not. So if you just declare it like this, then the map will be nil. If you declare it either way, this way or with the composite way, the map is not nil. It is empty, but it's not nil. The length of the map can be determined using a length function. So you can, like a slices, um, that map also, or the len function will also work for the map. It will tell you that, um, how big the map is, the size of the map basically. Okay, so let's look at the example in the next slide. So in this example, we are using a package main and the fmt package, and within the main body we are basically creating a nil map. Okay, so this is the nil map created. So the key will be of string type, and then the value will be of integer type. So at line number 6, we are checking after it creates the map, which is a nil map. Okay, it checks if the person salary is nil. Okay, it is going to go in at line number 7, and it will say map is nil, going to make 1. Okay, so then once it's nil, then you can use a make operator or the make function to create a map. So we already have the nil map. We can use that to basically allocate the memory for the map. So that's what we are doing. In this case, the key will be of type string and value will be of type int. And then we check by using a len function to check the length of the map. Okay, so when we do that, right now all we did is just created a map. It is still empty. It is not nil. After you did the map call to the make function, the map is not nil, but it is empty. Okay, so since it is empty, the length that it will give it to you will be 0. Okay, that's why you have a 0 in there. So now let's look at how you can add items to the map. Okay, so the syntax for adding the new item to map is the same as that of arrays. So it's pretty straightforward basically, if you have worked with the arrays in the past. So in example number 3-14, what we are doing is going to go and see how to add the items once you create an empty map, not the nil map, empty map. So empty map, once you use a make function, then it will create an empty map. Okay, so in empty map you have the data structure for map in the memory. All you need to do is to start adding the items to the map. So with the key value, that's what we are doing. So we are adding the key right here and then putting the value to it, key and then the value. So that's how. So in this case, it will have that length will be 3. Okay, if I do the length operator or the length function on this personal salary, it should print out 3. Okay, so basically in this case at line number 9, I am dumping the map. So when I'm dumping the map with using a print line or println function from the fmt package, it will give us the key and then the value. Okay, key and the value, key and the value that will be displayed. Okay. Let's look at the next example that will tell us how to initialize the map. So initialize a map during declaration using composite literal. Okay. Now we are going to be not using the make function. We will use a composite literal. Okay. So create a personal salary and add two elements to it during the declaration. So you can do that. If you want to use a composite literal, you can do it during the creation. Okay, um, of the map to add anything. So we are again in the main function, which is the entry point, and then we are um, creating a variable of type map personal salary. Okay, and using the composite literal right here. Okay, and initializing the map with this data, so key and value. Okay, key and value. So now we have that, and then we are, when we print the key value, the name of the map, it will print out all the data from within the map. Okay, so that's this first line, and then we modify the value for uh, Mike. So basically, in this case, we are saying Mike. Um, uh, so in this case, what we are doing is adding Mike to it. Okay, to the map. So instead of only two, now we added the third one. So we updated the map. Okay, so here, if I would have used the in this line number 11, if I would have used the ln, okay, function, then I would have got only two items. If I use the ln function right here, I will get three items. Okay, so because we added one right here, line number 12. All right, let's see how we can retrieve items from the main map. Okay, so let's look at how to retrieve items from the map. So map key is the syntax to retrieve elements of a map. So that's you got to know the key. Okay, and that's how you can retrieve it. So it's similar to, like, array. You need to know the array index to get the from that index you need to know what is stored at that location on that element. So if the element is not present, the map will return 0 value of the type of that element. Okay, so basically, if it doesn't matches, then you get the 0 value. So here again we are creating the map, okay, with the two items, with the key and value, and then we are saying, okay, once we have this, then we are saying Mike, okay, equals to this. So we are assigning the new value to the map, a new key value pair, okay, to the map. And then at line number um, 11, we just creating this employee is just nothing but a variable name of type string. Okay, and the reason I'm saying we are creating is because we are using a short declaration, right here, colon equal. So it will create this variable of type string, and it will initialize this data to this variable Jamie. Okay, that's all this is doing. So this 11, line number 11, doesn't really have anything to do with the map. Now at line number 12, now we are using this variable employee to see if Jamie is in the map or not. Okay, so salary of employee is, whatever it is, but the Jamie, well, Jamie is in here in the map, so it is going to display this number, because it found it. That So we provided the key and the value it will find. Now if I say salary of Joe, by that, by giving Joe, so essentially, at line number 11, I really didn't even need it. I could have just, uh, put Jamie right here instead of employee. So like I'm doing it right here. Okay, so in this case it is going to go and try to find Joe in the map, but there is no Joe in the map. Okay, there is no key value pair for Joe, so then we get a 0. Okay, so if the item is not found, then it will just return 0. Okay, now let's see how to, in the next slide, how to check for the key in the map. To find whether a key is present in a map or not, use the following syntax. Okay, so you give the key, and if it doesn't find the key, okay, then as you can see, this short notation will create two variables. One will be of type boolean, okay, and the other one, it will get the value from that key. Okay, so key value pairs, because that's what we want to be able to find out. So if okay is true, because this map will return either true or false. So if it is true, then the key is present and its value is present in the variable value. Okay, so if it is true, then there will be a value will be put into this value variable. Else the key is absent. So if it doesn't find the key, that means this okay will be false. Okay, and of course the value, it will have nothing in there. So in this example 3-17, we have the package main, and then fmt, import fmt, and then we have a body for the main, and in this body we are creating the map. Okay, and initializing it with the two data set key value pair. Okay, and then at line number 9, we are adding one more key value pair to the same map. And then, at line number 10, we are just creating a new variable with a short notation. And this is of type new emp, is of type string, that will be created. And then we are using this map to basically find out if that key is in the map or not. So if the key is in the map, then I want to be able to read the value. Okay, so in this case, I don't see the Joe in here. So this OK will be false. Okay, so I'm checking if OK equals to true. Well, it is not true. Okay, so it's not going to go in and do print this out. It will come to this else part and it will print out this, that it did not find Joe. Okay, so that's how basically you can utilize the map and find out if the key is in the map, so you can get the value out of that key value pair. Okay, all right, now let's look at the how to iterate the map elements, so that way you can basically go through the whole map if you use this for loop with the range keyword. Okay, so you use a range keyword form of the for loop. That's the one of the form that the for loop provides. We already talked about the range in the previous unit. So the range works the same way. Okay, so in this case, the order of the retrieval of values from map using the for range is not guaranteed to be in the same to be same for each execution of the for loop. So you can't just rely on it. It is it may be different for each execution of the for loop. So here we have a package main, and then we are importing the FMT, and then within the main function we are creating the map right here at line number 8. Okay, it is creating a map which will have the key will be of type string, and value is also going to be of type string, and we are using a short declaration notation to create the map type variable. So this is country capital map type variable. Okay, so and then we are using a composite um, um, uh, literal to create the map. Okay, by providing the key value pair, key value pair, key value pair. Okay, so that's what we are doing right here. And then once we are done, we are using the for loop to go through the map. Okay, so in this case we are using the for loop with the range keyword. So here basically within the for loop we are creating a country as a variable, okay, by using a short declaration notation, and when we go through the map it will find the country in the map, so that's what it is happening. So this is a map name, country capital map, and it is taking the key for the country, and then it will find the value, so basically when we give the country name as a key, then it will give us the value for that country. The value will be its city. Okay, so basically, or the capital. So at line number 17, we are using the same for loop with the range, but in this case, we are also getting the range is going to give us uh, or initialize these two variables, country and capital, by using a short declaration notation, and give us the key value for each from the each iteration of the for loop. Okay, so country and capital will be saved, so then we can just read it and display it. So that's how you can use the for range to with the maps. Okay, um, so let's see how in the next example. Let's see how you can delete the items from the map. Okay, the delete map and the key is the syntax to delete the key from a map. So delete is a function basically, and you use that by providing the map name, you know, and the key for within that map, and it will delete that entry from the map. Okay, so delete function does not return any value, so it doesn't return anything. It will just, you ask for deletion, it will just delete that entry from the map. So we create a map by using a composite literal, okay, with the two key value pairs at line number 6 and 7. And at line number 10, we are basically um, uh, creating one more entry in the map with a key value right here at line number 10. And then we are um, basically reading the map. So when we do that, it added the new key value pair, which is going to be right here printing. And originally Steve and Jamie was there. So as you can also see, when there is a key value, the map, when or the actually this is a part of the print line function, which really actually does the alphabetize the map. So you will notice in the other examples as well, always will alphabetize the keys, and and do the printing. Okay, but when you use a delete function and then give the map name, and then you tell which key that you want to delete. In this case we are deleting this guy right here. Okay, and it will delete it. So when you do the printing or displaying using a print line, now you have only two key value pairs. Okay, so that's how you can delete the the key value pair from the map by using a delete function. In this next slide, we basically wants to know the similarities between a map and a slice. Okay, and we kind of talked about quite a bit about the slices. That a slice have a descriptor. In the previous unit, or the unit 1, we went quite a bit detail about what the descriptor is. Okay, and we said that okay, it has three types. It has a pointer that points to the underlying array, it has a length, okay, and it has a capacity. So these are the three things in the slice descriptor. Okay, but but the map really doesn't have that kind of a descriptor, but map has something different. But notice that the descriptor that we are talking about, the slice, that has that has this pointer, right, in the descriptor. Similarly, map also has a pointer, but a map doesn't have the for example capacity in there, in whatever the data structure that the language provides for for the map. It doesn't have the capacity. Okay, so that's why that's the kind of a difference between it. But they both have a pointer which points to the actual data, which what is um, what is allocated for maps, key value pair, and for slices underlying array. Okay, so but for the uh, for the maps, uh, you you create a variable of type map using uh, this make function, or of course uh, composite literal. But under the hood, it when you use a make function, under the hood it calls this function make map. Okay, that is a function which is called when you just make a call in your code. You just use this make. Okay, and then this function, what it does, it returns this pointer h map. H most probably stand for hash map. Uh, so that is the pointer which holds the address of the all the key value pair which are allocated in the memory. Okay, they are all in the memory. So this pointer basically has the address where they are located in the memory. So that's the key part in similarities between a pointer that is pointing for the slice in the descriptor that is pointing to the underlying array, and the pointer which is h map for the maps. Okay, when maps are placed as parameters to functions, changes inside the function are visible to the caller. Okay, so basically you when you pass a map type parameter to a function, and when the function returns back to the caller, the changes will be visible to the caller. So when a map is assigned to a new variable, they both points to the same internal data structure. Okay, so basically the data structure internally that is created, they both will be pointing to the same data structure. So therefore changes made in one map variable will reflect the other map variable. Okay, so they both will have the see the change. Okay, and that is we can prove it with in this example 3-20. So in 3-20 we have the package main, and then import the fmt package, and then create a map with these two key value pair. Okay, so personal salary is the map name. The key is going to be of type string, and value is going to be of type int. Now at line number 10, we are adding a new key value pair to this map, personal salary. Okay, so we have three key value pairs in that map, and then we are printing right here. So all three will be printed, as you can see right here. Jamie, Mike, and Steve, they all will be printed. Okay, and then we create a new map. Okay. Now we already know that this personal salary is of type map, that variable. So all we are doing is we are doing using a short notation, and when we uh, just like if you would have some variable of type int, and you want to create another variable with a short notation, the other variable, if you assign one variable to another variable, the new variable will become the same type. So same thing is happening right here. New personal salary will be of the same type of this personal salaries. The personal salary of type is map, so this will be of same type. And basically the pointer that this has, you know this pointer, h map pointer, remember underlying this H map was is there. So that is holding the address of where this all this key value pairs are in the memory. So the same same thing will happen with a new personal salary. It will also have the H map pointer in it. Okay, so they both will be holding the address. So to make us understand a little bit more, let me just draw the some pointers right here. This is one uh, pointer which is h map. Okay, and that is for new person. Okay, and then this one, another pointer which is for the old one. Okay, which is basically, I would say, all the key value pair somewhere in the memory, some data structure in the memory at some address location is there. Okay, there is a key value pair right here, and this address is in here. Okay, and this is also is a h map underline. So this pointer is pointing to this key value pair, which is in the memory. Okay, and when we do this operation, what it does, it copies this same address, okay, to right here. So this one is also pointing to the same key value pair. Okay. Now, when you do this guy right here and adding a new key value, okay, you basically are saying that, okay, are you modifying the uh, value for this key mic. You are coming to this memory right here where mic is here, and you are modifying the and putting here your 1800, for example, instead of a 900. Okay, it finds it. So basically it is happening because the new person salary and the original person salary, they both are pointing to the same place where all the key value pairs are located in the memory. And because the way that we initialize this new type of a map variable. Okay, and especially for because underneath it is utilizing this h map, and which we already talked about above. So that's how this H map is used. So you don't have to create your own separate pointers to hold, anything for the maps. Now, let's look at this other example in the next slide. And in this example, basically, we have a function, okay? And within the function, we we would want to add a key value to the same map, okay? So let's see how it works. So the map is passed as a function parameter, okay? So as you can see, this map is passed as a function parameter. Again, remember, in Go language, whenever you pass anything to the functions, they always are passed by value. There is no such thing as pass by reference unless you specifically pass something that you want to pass as a pointer, okay? So that's the one major thing that you should remember. So in this case, the map is passed by value, okay? And changes inside the function are also visible to the caller. Now, we went over the similar thing in by passing the slices by value, okay? But in that case, if we wanted, when we were passing it, there was some different things was happening, okay? And you can go and uh, uh, go over that unit to understand more what was happening when we talked about passing the slices by value, okay? And then we pass the slice as a pointer. So in here, for the map, you don't need to pass as a pointer. You can just pass as a value, and because of each map that in the previous slide that we talked about, it will keep the address in this pointer where all the key value pairs are located in the memory, okay? So what is happening right here is that in the main function we create a map right here, okay, at line number 10, and we have the variable of type person salary. Now, in this case, this variable will have these three key value pairs. Okay, these three key value pairs will be there, and then when I at line number 14, when I do the person salary, okay, before the call to the add name, I will get these the print line function will print all these three key value pair, okay, like you see it right here. Jamie, Mike, and Steve, all three are printed. Of course, they get sorted, and the sorting occurs because of the print line function, and it sorts it on the key. Okay, so that was before the call to the add function, add name function. Now, at line number 15, I'm calling the add name function and giving the person salary variable of type map, okay? So it goes in here, the parameter of the function add name is of type map, okay? And when it goes in there, so it is basically having the same effect as what we talked about in the previous example, that underlying H map will have the address of all the key value pair which are in the memory, same address that it will have for. So basically, when we have this person salary, person salary, uh, person salary, so that is a variable that has h map, okay, which is holding the address. Maybe the address might be 5,000 for this key value pair. Okay, so this is 5,000, so it's pointing to right here. And when you pass this to the function add name, you are actually copying this address to the h name which is right here, okay, in for this parameter, for this name, or this map item is the name of the map. So that will be holding 5,000 as well, okay. So it is pointing to the same key value pair. So when you try to do the modification or add another key value pair within the function body, it will be added to this. And when you come out and print the person salary from within from the caller of add name, which is main, it will be able to see this key value pair as well, and it will print that. And that's why the GIL shows up right here, okay. So that's how it is basically uh, mm, uh, uh, that's the reason that you do not need to create a pointer type map in the parameter for the function, okay. And that's the key difference between a slice and a map for the passing the parameter to the function, okay. So that basically concludes this um, unit, and we will this unit, unit 7, we will go move on to unit number 8, okay.